Hello, everyone. My name is Sarang Patel. Thanks for joining us today. My role is Chief Strategy Officer at a company called Contrast Security. Luckily for you, I only have pictures on my slides today, so you don't have to worry about the small screen here. But I'm really excited to walk you guys through briefly what Contrast is doing to usher in the era of self-protecting software. So as we all know, Marc Andreessen is right. Software really is eating the world. Ask any taxi driver, bookstore owner, or news reporter. But the key piece that we always think about is software is really changing the world, but at the same time, every line of software we introduce also introduces some more risk for us. As we push forward, I don't know why it's not working. As we push forward, software has continued to change over the last 20 years, right? We continue to find faster ways to deploy software, quicker ways to make it more performant, and add new features as fast as we possibly can. During that time, security has been really tough to keep up with that process, right? This year, it's estimated there's going to be 111 billion new lines of code written across the industry, and I think a big part of that is going to be every new line of code also introduces more risk. And as we introduce more software, how do we continue to make sure that we can introduce software quickly and fast, but at the same time not introduce more risk to all of our businesses? Before I jump into security specific about what we do, everyone always asks, there's so many, everyone's in security and everyone has to think about security, but what specifically does Contrast focus on? This is a framework that actually Bank of America uses to think about every security product in their portfolio. Across the top is a NIST cybersecurity framework, and across the side is the different elements of their total IT environment. Where we're focused squarely is on the software application layer, everything from identifying issues, protecting yourself, detecting issues, or attacks actually, and then being able to respond to those issues. So what does Contrast do? Contrast uses a technical approach called instrumentation. That's about placing sensors throughout your application, or your software application, to provide self-protecting software. The first question I always get is, what's self-protecting software? Self-protecting software is really two fundamental pieces. Number one is, during the development process, the QA process, the security process of building out your software, it's finding the weaknesses in that software. So those are typically weaknesses written due to poorly written code, or lack of security expertise during the development process. And so that's about finding the weaknesses in the software and plugging those gaps before you ship your software, before you deploy your software. Now, the second half of self-protecting software is about, once your software is deployed, being able to monitor it for any attacks that may be happening against your software, and then being able to block those attacks as well, right? So at the end of the picture, self-protecting software for us is the ability to protect yourself from the second you write some code all the way through that software application running out in wherever it may run, whether that's in your environment, in the cloud, in a container, doesn't really matter. It's embedding security into your software from the second it's being written all the way through production. Well, there's really two core products to this. This is the first half, which is the development side. This is just kind of to give you a really quick example of what that means. So a developer writes some code, they do a local test on their machine. Instantly, we will see the vulnerability that's in that code and tell them, hey, there's a vulnerability in this code. Here's where it is. Here's how to fix it, right? In this example, it comes through a Slack alert. We have many other forms of getting that information back to the developer, whether it's through a bug track or some other system. And the key thing here that really makes it scalable is that it doesn't have to do with security expertise. It's really about this notion of embedding those sensors in that software. The protect side is the other half of the picture. Now, when that software is running, you break it up into containers, into microservices, you deploy it in the cloud, on Amazon or locally. It's really all about seeing any attacks that are happening and then being able to act on that to protect yourself. There's two things that really fundamentally make us different from the last 2 decades of tools in this space. Number one is our accuracy. I'll talk about that in a second. Number two is the continuous nature, and they're not one word, they're 2 words, but the continuous nature of what we do, which is those sensors are constantly providing feedback. It's not a waterfall type approach, which has been used in the past. There is no scan button in our product, there's no start and stop button, it's constantly happening. Those two pieces allow our customers to achieve what they've always wanted to achieve, which is automation and scale in the sense of software security. Why are we more accurate? People ask us this all the time. It's not magic. It's not just that there's smarter people in the back room. It's really fundamentally about data. Traditional techniques, static techniques, and dynamic techniques, they only can see a bit of the picture, like the code or the HTTP traffic. We can see that as well as a bunch of other stuff as part of your software, including the third-party libraries you're using, the open source stuff that's there, and any live traffic that's happening. people ask us, can you prove your accuracy? This is one thing we show. It's a industry consortium that's built out a test bench that we can use and that we perform 100% on. And then they talk about scalability. So how can we actually achieve being able to protect our entire portfolio, which has always been an issue for many large enterprises. They decide and they pick which are their most risky applications and start there, which is probably not the smartest thing that they can be doing. Finally, this is a topic that's very hot for anyone in the development space. DevOps is a very constantly talked about initiative and methodology. It's really about building software as fast as you possibly can in a very efficient way. What we do is really enable that process. How? Because during the development process, it's about finding vulnerabilities quick and easy in a very accurate way, feeding that information back to the people that can act upon it, whether that's a development team, a QA team, a security team, whoever that is, being able to constantly give them the data that they need to be able to act upon that. And then during the operational side, as your software then gets deployed out, whether that's in Docker or Pivotal, Google, Amazon, doesn't really matter. It's about knowing there's information that you can stop on. All right, thank you.
Wonderful, perfectly on time. Thank you, Zerak.
Thank you.